Section 8.1.13, complete parts A through D for the sampling distribution of the sample mean shown in the graph here. Okay, so the sampling distribution here, we have the distribution is normal and the locations of the peak and inflection points are shown. So 200 is the mean, and then here are our inflection points. So for part A, we wanted to determine the value of the mean of the sample distribution. Okay, well, it's going to be the same as the mean there, so we know that the mean of the sampling distribution is going to equal 200. Okay, so now what we want to do is we want to determine the value of the standard deviation of the sample means. Okay, now note that the left and right points shown in the graph are inflection points. And recall that inflection points are the points on the curve where the curvature of the graph changes. So for a normal curve, the inflection points are the points at x, which is equal to the population standard deviation minus the mean minus the standard deviation, and x is equal to the population mean plus the population standard deviation. So to the left of that and to the right of that, the curve is drawn upward. So in between, the curve is drawn downward. So for this particular problem, okay, what do we know to the right? Well, we know that to the right point, we can see that so to the right point, we see that x bar is equal to 225. Okay, and then we also know from part A that the mean of the sampling distribution is 200. And so what we're looking for is the standard deviation of the sampling distribution. So we're going to use the following formula. We know that x bar is going to equal the mean of the sample means plus the standard deviation of the sampling mean, which means that we're using the following formula, and I want you to pay close attention to that. This is to the right, right? So we know that to the right, we saw that this was x bar. And so this is the formula that we're using to get that result. So therefore, we know that x bar is 225. We know that the mean is 200, and we want to find the standard deviation of the sample means. So what we can do is, now if we want to solve for the standard deviation of the sample means, we're going to subtract 200 to both sides. So it's going to be 225 minus 200. So therefore, the standard deviation of the sample means is going to equal 25. Okay, so now the next question is asking us if the sample size is 25, determine what must be true about the shape of the population. So recall, the distribution of the sample mean is normally distributed when the random variable x is normally distributed, or when the sample size is large at least 30. Now notice that in this case, the distribution of the sample mean is normal and the sample size is small, where it's 25. So the sampling distribution of the mean is only normal when the population is normal or the sample size is large. Thus, the shape of the population must be approximately normal because the sample size is not large. Now in part D, it says now if the sample size is n equals 25, determine the standard deviation of the population from which the sample was drawn. So recall what our formula is for the standard deviation of the sample mean. Well, that's equal to the population standard deviation divided by the square root of the sample size. So in our problem, okay, in part B, we know that the standard deviation of the sample means is 25, and we know that the sample size is 25. Okay, so what we're looking for now is the population standard deviation. So let's go ahead and put that in our formula here. So we know that this represents 25, and that's equal to the population standard deviation divided by the square root of 25. Okay, so let's continue to solve here. So we have 25, which is equal to the population standard deviation divided by the square root of 25, which is 5. And now we're going to multiply both sides by 5 in order to isolate and solve for the standard deviation. So that means that we're going to take now the standard deviation, this becomes a 1, and so we have 5 times 25, and so therefore the population standard deviation is 125. So therefore we can say that the standard deviation of the population from which the sample was drawn is 125.